The move to highly automated vehicles is creating significant changes in the computing architecture approach in vehicles. From an older approach of feature-specific ECUs with many different computing boxes put into a car, there's a move to significant centralization to a smaller number of highly capable computing platforms. An implication of this, however, is that the vehicle integrator needs to integrate different features and pieces of software from different suppliers and different in-house groups into a single computer, which requires a lot more coordination effort. There's also a change from a fail-silent to a fail-operational strategy. When the driver was able to take over after computing failure to manually control the vehicle, fail-silent on individual features was arguably okay. But now the computer has to keep driving the vehicle even after something has failed, leading to requirement for significantly more redundancy. Redundancy alone won't solve the problem because if all the redundant channels fail at the same time, the redundancy didn't do you any good. Therefore, there's a need for diverse, different channels doing different strategies for controlling the vehicle, which is significantly more complicated and significantly more resource intensive than for older vehicles.